sum of parts for for automated machine quality inspection. So I'd love to welcome anyone from Sum of Parts to come on and present their solution.
Yep. Hi, I'm Sense. I'm from Sum of Parts, and we worked on Challenge 1 with machine vision. Next slide, please. So our solution is so that we have a camera, which is connected to a Raspberry Pi, and then we run a model, which can be sent via cable or Wi-Fi to a computer. Ours was based on bottles, so to detect if it's a bottle, if it has a lid, scan its barcode and see its height. And with computer vision, we used transfer learning, and we decided on using a pre-trained YOLO v3 model using an open source library called Image AI. And we were able to identify bottles from lab cameras with high confidence. So 94.1 accuracy on 640 test images from a Kaggle data set. And you can see in the GIF below a demo of what we did.
We were able to scan barcodes in both orientations, as well as measure the height of our objects via camera. As you can see below in the table, our final prototype marks the time the image was detected, fails past the product type, scans the barcode, and all of this is exported continuously to an external spreadsheet file. Next slide, please.
After doing the cost-benefit analysis of each component, we found that the optimum component in terms of the functionality and the price are LED lights for £13, 1080p camera at £28, Raspberry Pi 4 as opposed to Raspberry Pi 3 for £30, which costs us a total of £17.
So we use Image AI as our open source library, and it was easy to use. We also used 50 images to train, and we got 94.1%, so it was good accuracy, and it can be scaled later easily. We also used Google Colab GPU to train, and it was free. Next slide, please. So the benefits of using our solution to SMEs, so it's the repeatability, so we can focus human resources in other areas of interest later. The productivity, so it can be run 24/7, and it has a high level of accuracy.
Our product automatically collects data and focuses its object detection and analysis on the object that we want, so it ignores all other types of products. Additionally, it's very flexible, as it can work from real-life feeds via webcams or also pre-recorded videos, and also has very high adaptability, as it can be used for any other product just by changing the weight file. It also needs very little setup, and so is very easy to use.
Other non-QC applications could be to track stock and production real time. It could also be used to improve security, such as tracking people in a lights out factory or even facial recognition. And for all these reasons, we believe that our solution will be useful to SMEs. Thank you.
Thank you very much, Sum of Parts. Do we have any questions from the judges?
What sort of speed of movement of products could you cope with, do you think?
So as you can see from the demo, we tried to replicate a conveyor belt. If you go a bit faster, sometimes it gets confused, but we can also adjust the sampling speed as well. And that helps with the accuracy of the recognition.
So where do you configure for new products? Is it just some text files that you're saying, and have to provide it some images to learn from?
Yes, so we only used 50 images. You just need a good variety with other objects in it. We have our own Colab notebook that we put in there. You just need to zip your images, upload it, and then train and download the weights.
Hello, I've got a question as well about the accuracy level. You mentioned 94% being quite high, but that's not really high enough. So what would actually allow you to get it up higher than 94%?
I think it's because we weren't able to train it well enough, and also because the data set that we trained it on is quite small. I think if we augment the data and also add in other things so that it doesn't overfit our small data set, it will raise the overall accuracy.
Okay, thank you very much to the sum of your parts.